Hello, so this is section 4.3 on trigonometric ratios. So in class, we've already looked at special triangles and found the exact values of the following trigonometric ratios. And this table is filled in. So the first thing we're going to look at here is, in general, if any xy is on the terminal arm of some angle in standard position, this is what it will be like. So we have some point. Again, we're going to think of as just a circle here. We're going to say the origin is at the center. I know my circle is not perfect. And we have some point x, y. And this is on the terminal arm at some angle theta. So we draw a line straight down. We know that the height is basically our y, the horizontal is basically our x, and our radius is basically what we'll call r, okay? And when looking at our three trig ratios here, we have sine, cosine, and tangent. We know the relationship through SOHCAHTOA. When looking at sine, it's opposite over hypotenuse, which in this case is y over r. Cosine is adjacent, which is x over hypotenuse, which is r. And tangent is opposite over adjacent, which is y over x. Now, if we look at a point with some angle, if it's equal to xy, and now this is on a unit circle, now what would that look like? So again, we have a circle. Origin is the center, and we have some point xy. And again, this is also lying on the terminal arm and on the circle at some angle. So again, x is on the horizontal, y is the vertical, but a unit circle, remember, has a radius of 1. So instead of just r as the radius, we have 1. So now our trig ratios will slightly change, and we're just going to look at sine and cosine here. So sine basically will now be just y over 1 instead of r, and cosine will be x over 1 instead of x over r. Now, since it's just over 1, we could just simplify that to y and x. And we see the fact that y and x are the points on the circle, but it's also equivalent to, y is also equivalent to sine theta, and x is equivalent to cosine theta. So we could basically replace sine and cosine into the points, and we could say a point on the terminal arm at some angle can be also written as cosine theta sine theta. Okay, and this is, remember, this is only for unit circles, so not for all circles, but just when we're dealing with a unit circle scenario. So something else to add is reciprocal trig ratios. So sometimes when we flip those trig ratios upside down through a reciprocal, they actually come with new names. So the first one is called cosecant. And it's short form written as CSC. Do not be fooled. This is actually the reciprocal of sine theta, not cosine, sine. So since we found the reciprocal, the ratio will also be reciprocal, so now it's r over y. Next, we have one called secant, and this is short written as SEC, and that is 1 over cosine, and that would be r over x. And last is cotangent, and that is COT theta, and that is 1 over tangent. And that will be x over y. So just one thing to be mindful of are these two up here. So cosecant actually goes with sine, and secant actually pairs up with cosine. So when you're looking at reciprocal versus the primary, you do need to flip the C and the S, okay? So don't pair them up based on the same letter. First example here. So there's a point A, -3/5 and -4/5 is on a unit circle. So remember, unit circle r equals to 1. And the terminal arm of standard position angle theta. So it's on a unit circle, on the terminal arm, and has an angle theta. So let's start with just a sketch of what that may look like. So we have our unit circle. So since we're looking at x and the y value being negative, so remember this is just a point, that means we're in the third quadrant. It's gonna say it's somewhere there-ish. Just gonna put an arbitrary point. Just make sure it's in the white quadrant so you can visually see it. And we do know that it's a unit circle, so this part is just 1. Please note, r is always, the radius is always positive. Okay, so the height, the y value is -4/5. That can be negative, and the x is -3/5. That can also be negative. So now that we've done our sketch, we do know we need to find 6 trig ratios and 1 value of theta. So let's just first start with the 6 trig ratios. First, I'm going to start with what we call the primary trig ratios. These are the ones we are familiar with, which is sine, cosine, and tangent. So remember, with sine of a unit circle, we're really just looking at the y value, so that's just -4/5. Cosine is just the x value, but tangent is still going to be y/x, so it's going to be -4/5 divided by -3/5. When we're dividing two fractions, we can just multiply it. So we 5/-3. 5's cancel out. So you do have, and the negatives also cancel out, so you have 4/3. Next, so we only have 3, the other 3, we need 6 trig ratios though. So the other 3 are those reciprocals. Trig ratios. Okay, and in this case we have cosecant, secant, and cotangent. So cosecant is just sine, but reciprocal of that, so just 5/-4. Secant is just the reciprocal of cosine, which is 5/-3. And cotangent is just the reciprocal of tan, which is 3/4. So now we got the trig ratios done. Cool. Next, we do need to find one value of theta. So we do need to find that. So we do know the angle from standard position. Start from the initial arm, and we're going to go all the way around. But to find that, we do first need to find out our reference angle right here. So this is our reference angle, whereas the black part is just the standard position angle. So we do need to find our reference angle first. So if we kind of magnify this triangle, if we kind of separate out the triangle, so this is our angle, and this is our side, -3/5 and -4/5. Okay, and this side is going to be 1. So to find the reference angle, we have this triangle, but one thing we need to be mindful of is the fact that when we're calculating reference angle, we do need to be dealing with a positive ratio. And we could actually use any of these trig ratios. So I'm just gonna pick 10 in this case. Okay, so we're gonna pick 10, and we know that is gonna give us the reference angle, and the ratio is 4/3. I'll just put a note here, put a star. Ratio needs to be positive. Okay, so I already picked a positive one, but if you decide to pick cosine or sine, you can still do this same procedure, but just make sure you change that negative sign to positive to find your reference angle, okay? So from here, we're just going to use arctan, so we know our reference angle equals to 10 here, 4/3. And we know that our reference angle, depending on what kind of angle you're looking for, you will either have 0.927 radians, or you'll have 53.13 degrees. Ooh, running out of room here. So now that we know our reference angle, we can calculate our standard position angle. So our angle, SP, is a combination of either 180 plus our reference angle, in which case we have 180 plus 53.13, which leaves us to 233.13. Just put that box here. Or for those of us who decide to write in radians, it's going to be pi plus 0.927. I'm okay with you just leaving it like that. There's these two options here, okay? Okay. All right, next example. Example 2. So we have a point, -3,5 is on the terminal arm of standard position angle theta. Find one positive and one negative angle of theta. So let's just, again, sketch this out. So we have a point on -3,5. That will actually be in the second quadrant. -3,5. Oops. Let's just say it's there. -3,5. Okay. And we can kind of just sketch a terminal arm. Now we do know, think of this as a triangle. This time, so we know this is -3 and this is 5. But this time we don't know what the radius is because it doesn't say anything about unit circle. So we will need to find out what r is. So that's when we'll bring out the handy Pythagoras. So r squared equals to 5 squared plus 3 squared, which gives us 34 r squared. To get r by itself, you do need to square root it. Okay, so r equals to root 34, and we'll just leave it like that. Equals to root 34. So now that we have this, then we do need to find out an angle. So with the angles here, with the angle here, we're looking for either from initial arm, we could go this way to be positive, or we'll have to go from the initial arm in the clockwise direction, and that will bring us the negative, okay? But before we can figure that out, we do need to find out a reference angle so we could actually make that comparison. So in this particular case, again, you could pick whatever trig ratio you want to find that reference angle. I'm just going to pick cosine this time. So we know cosine of this angle is equivalent to, which is going to be adjacent over hypotenuse. So remember, needs to be a positive ratio, even though it's -3. For reference angle purposes, change it back to positive. So we have this ratio here. If you do the math, your reference angle will be at 59.04 degrees or 1.03 radians. So now that we have our reference angle, then we could find our angles, our center position angles. So I'm just going to pick the angle positive will be 180 minus our reference angle, which in this case is 180 minus 59.04, which is 120.96. Okay, that's one angle. If you want to calculate in radian, that's pi minus 1.03. Okay. Next, we have our angle negative. This case will be negative 180 minus 59.04. Make sure you put the little circles to represent degrees, equals to negative 239.04 degrees. That's one. And again, if you want to write in radians, it'll be pi minus, or negative pi minus 1.03. That is a second option. So that's your one positive and one negative angle. All right, example 3 here. Solve cosine theta equals to -1/√2. So with this, first we want to start with kind of a sketch again. Now, how do we know where our terminal arms are? So we need to look at this ratio. And right now we have a negative ratio. And if you think back to PreCal 11, we learned kind of this acronym, which is ASTC, also known as all students take calculus. Or some other students just like to look at it starting from here. And if you go up, you could think of it as CAST. It's up to you how you want to memorize it. But basically, what this means is in the first quadrant, in quadrant 1, all the trig ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, it's only tangent. And in the fourth quadrant, only cosine. So right now, we're looking at cosine is negative. So therefore, we know it must be in quadrant 2 and quadrant 3, because cosine is positive in quadrant 1 and 4. So next, we do have kind of like a restriction here. We're only looking from 0 to 2 pi. So that means we're only going in the positive angles. So starting from the initial arm, we're only going to go once all the way around. So to hit our terminal arms, here is one option. And then we start our terminal arms again, or our initial arm again, we can hit that second one. So there's kind of two options here. Okay, and to figure out our standard position angles, we do need to figure out our reference angles. And we do know that these two reference angles will be the same because they come from the same ratio. So to find our reference angles, we know it's cosine of the reference angle equals to 1/√2. Another way of writing 1/√2 is equal to if you kind of rationalize the denominator, is actually root 2 over 2. Now, looking back to our chart from the beginning, I'm just going to scroll really quick up. Whew. Root 2 over 2, well, this is the one we're looking at. We know when we have the angle pi over 4, that is the ratio we should get. So from our table, we know that our reference angle must be pi over 4. So now that we know our reference angle, then we can calculate what our standard position angles are. So for angle 1, we know it's pi minus pi over 4, which gives us 3 pi over 4. Have to subtract it. Whereas for our second angle, we know it's pi, and we're going to have to add on top of that pi over 4, which is 5 pi over 4. Okay. So please be mindful if the kind of restriction given to you here is in radians, answer in radians. If I do give you degrees, answer in degrees. Okay, last example of the day. So solve cotangent theta equals to negative root 3. And again, our restriction is from 0 to 2 pi. Otherwise, you'll be giving me infinite number of answers. So again, we'll just draw out kind of where things are. So cotangent, we can actually just rewrite that as 1 over 10 theta. Actually, maybe I'll just write it on the side here. So cotangent theta equals to 1 over 10 theta, and that was negative root 3. So if we kind of just reciprocal, flip it around, we do know that we're looking at tan theta equals to negative 1 over root 3. And if we rationalize that denominator, we're at negative root 3 over 3. So knowing that, we still have your all students take calculus. Since this is a negative ratio, so we're going to be in quadrant 2 and quadrant 4. Now we're looking at from, let's see, we're going from initial to 2 pi, so it could be here. That could be an option. Or we'll have to go all the way around to here. That could be option number 2. So there are two angles here. Again, we're just going to have to figure out these angles by first finding our reference angle, which is here and here. So we know it's tan theta. Our reference angle is going to be equivalent to the ratio, but in the positive form. Now, we can go and check our table. So we're looking at tan of some angle is root 3 over 3. Scroll up. And we see, this is the one. I'm going to erase the last one. This is the one we're looking at. We're looking at tan pi over 6. So we know our angle is pi over 6. So knowing that, then we can, again, figure out our angles. So for the first one, it's pi minus our reference angle, which is 5 pi over 6. And for angle 2 is going to be 2 pi, actually, minus our reference angle, which is 11 pi over 6. Okay. And that is it for today.